Greetings and welcome to this presentation titled More on Test Bias. The goal for this is to provide a brief update on the latest knowledge that we have for how to statistically ascertain whether there's test bias occurring in our selection measures. And the information is primarily from an article that is on SharePoint, and it is by Mead and Fetzer, and it's in Organizational Research Methods. And so they provide a fairly readable document, but it is still probably too technical to have as a required reading for this course. It's more for reference, so I'm going to hit the highlights and talk about how to test for test bias. I'm giving you, I believe, everything you would need to know to pass a job interview on this question. And then when you're actually going to do the statistical testing, you can always refer to the article itself. Okay, so let's do a brief review here. Some of the common terminology that we use. First, remember unfair discrimination. Please memorize this. It's when we have people who have equal likelihood of doing well in a particular position have an unequal probability of being selected for the position. So this is something that, of course, as HR professionals, we are always working on and trying to avoid this kind of scenario from happening. Remember, test bias is when we have either intercept bias or we have slope bias. And I'm going to put some further nuances on that here. Mead and Fetzer talk about test bias conceptually in terms of criterion contamination. Predictor contamination. So construct irrelevant variance. And not just any construct irrelevant variance, but irrelevant variance that is correlated with group membership. So this test gives one group an unfair advantage. And since it's construct irrelevant, then it's undesirable and we want to get rid of it. Remember, AI is a violation of the 4/5 rule according to uniform guidelines, which is still the standard by which we all adhere in the IO field, even though they are a little bit dated. Remember, too, that Bobko and Roth talk about testing for AI with significance testing instead of the 4/5 rule, so understand the arguments behind each one of those. And remember, AI and test bias can be linked, but not necessarily. So test bias can cause AI to occur, but we can have an unbiased test that still results in AI. And so if a test is not biased and AI is still occurring, we are technically not legally obligated to change our test or to do something else with our selection process. However, we as the organization may want to voluntarily do some things differently to reduce that AI. And so I'll talk about some of that as we go through. Okay, so case one. This is the worst case according to Mead and Fetzer. And if Guyon were around, he would agree, because we have a very large difference between the two groups on the predictor score, but on the criterion we have an equal or nearly so performance on the criterion. And so that means that both groups are performing equally on the job, but the selection test is putting a big gap there for some reason. So that is not good. Mead and Fetzer again say that this is probably a case of real test bias, and this would result, of course, in unfair discrimination. For case two, we have intercept bias again, but it looks slightly different, and that is that it's the opposite. In this case, we have the same predictor score, or nearly so, but we have a difference in the way the groups are performing on the job. And so Mead and Fetzer talk about a couple of reasons for why this might be going on. First, we may have bias in the performance ratings. So if a supervisor is giving one group higher ratings than the other, and it is not true, it's not true performance that they're measuring, so this is criterion contamination, then that is an issue that needs to be addressed. And this pattern of findings would be indicative of that. But there's another pattern of findings that, or I'm sorry, another scenario that would result in this pattern, and that is that we're not using a particular predictor in our selection test battery that is actually important to explaining performance. And so what's happening when we're not using that is that the groups are scoring the same on our predictor that is not correlated with group differences. However, it's showing up in the criterion, these differences. So Sackett in 2004 wrote a piece, I think in JAP, and he used U.S. Army data. Surprise, surprise. In our field, it's like we're always using Army studies, right? And he showed this effect happening when personality was the only predictor that was used to select, I forgot what the job exactly was, but it was a job where obviously cognitive ability was an important predictor. So they saw no group differences on personality, but because cognitive ability drives performance apparently in those particular positions, that's why this gap occurred between the groups, is because they would have scored on this cognitive ability test differently, and that was predicting performance. Okay, so again, there are group differences on ability but not personality. So if you select only on personality and not ability, then we may see this scenario happening. Okay, so again, with this pattern of findings, there are two possibilities you'll want to look into as the HR professional. First, how are people being rated, and are they using cues that they shouldn't be paying attention to when rating performance? And secondly, you'll want to look at your selection battery, and if you are using a selection test that doesn't result in group differences, which is good, but it is correlated with performance, and if you would use another test, you will have group differences, but you'll also have better prediction probably. You as the HR professional may choose not to worry about this if you kind of conclude after your investigation that it is not the criterion contamination that is happening, that the ratings are fair to your knowledge, then you may not want to use another selection test that does create group differences. That is a risk that you have to think about as the org if you want to go there. And some do, and as long as it predicts performance and doesn't result in test bias, you probably will be fine by the legal standard. So those are decisions that you would make. Okay, case 3 is the no bias case, and this is the ideal scenario where you do have group differences on your predictor, but they result in equal group differences on the DV, and so you're okay, you're good with the legal side of things here. And this is a good scenario, except it will produce AI, so you want to think about that maybe, as I alluded to before. Maybe you will think about ways to recruit people from this group who are more qualified for the role, and so they're not scoring so low on the predictor and the criterion both. So I want to think about moving these closer together if you can, these scatter plots, and attracting, recruiting qualified applicants from both groups into the org. Okay, so Mead and Fetzer talk about case 4, which I had not heard about before till they came out with this article, and that is, but it makes sense. I mean, it's not rocket science. It just is an issue when you have unreliability on the predictor side, Unreliability, remember, always makes our validity go down, so it will make our regression lines flatter. So when you separate groups 1 and 2, you won't have lines that are superimposed. They'll be flatter. And so if both of these were more, if we had, okay, let's put it this way. If we had more reliability, Mead and Fetzer argue that more reliability will cause both of these to come together. So higher reliability would have caused the regression line to bisect the two groups, and that would have that is indicative of no test bias in this case. But without knowing this, you'll conclude that there is intercept bias perhaps, because you have, again, this big gap on the predictor and a gap also on the criterion. It may be a little bit smaller, but still an issue, could be. But when you have unreliability, that could be what happens. Okay, so Mead and Fetzer say that this is a case where it's not real intercept bias, it just looks like it. And so we could have a line that bisects the two groups and that they would be superimposed. So unreliability on a predictor makes regression lines look flatter than they would be. And so, but if we had perfect reliability or better reliability, then these lines would come together. Okay, so the goal is then, how do we know if intercept bias is real, or if it is, if there are other things going on? If there's omitted third variables, or if there's unreliability issue, how do we know what's real and what's not, and how do we parse that out? And with the Cleary model, the traditional one that we've used historically, 1968, I believe, we wouldn't have a way to parse out these two scenarios. We wouldn't know whether the bias is real or not. But Mead and Fetzer do have a way. Okay, so to review, summary of their arguments: differential slopes always denote test bias, so that's important to note. So that is always an issue. Excuse me. But different intercepts, that is another case. So if we see differential intercepts, it could be that the test is biased, but not necessarily. So different intercepts can be caused by either bias or, pardon me, or other things. So like omitted third variables, like we talked about, unreliability in the predictor, and then finally, remember, criterion contamination in the performance ratings. So at the notes at the bottom of this slide, I've put in the steps that Mead and Fetzer talk about on page 750. Pardon me. For testing, for ascertaining whether there's test bias happening. And the bold terms are, correspond to Table 2, the information in Table 2 that they provide in their manuscript, which I will go over here in a second as well. But first they say, and when we start the process, we take the group test scores, the predictor test scores, and regress them on group membership. So remember, that can be 0, 1 for two groups if we just have two racial groups or gender, or remember, we have to dummy code for 3+ groups. And so this is where all of the information from regression comes in handy, thinking about this process. Also, you can conduct a t-test or one-way ANOVA, and to understand if there are differences across groups on the predictor. So this is called the predictor test. And this is one step to figuring out if test bias is happening. If you see difference in the groups at this stage, this is a necessary but insufficient condition for test bias. So if you see this, it could be that test bias is happening, but not necessarily. The second step is you do a criterion test. So after everyone's hired, you have their performance scores, you want to see if the groups differ on their performance by group. Sorry, that was redundant. See if the groups differ on performance. Okay, so a t-test or one-way again, one-way ANOVA. Finally, in the third step is your traditional MMR. And so for these steps, by the way, know them for the final exam. Know how to run this in SPSS as per the instructions from regression, and the different things that contribute to the power for an MMR. What are the costs of type 1 and type 2 error in this context? And also, Mead and Fetzer don't talk about type 2 heteroskedasticity, but that matters for this test in particular. And so we want to use a Guinness's Alt MMR for this test. Again, to try to be as accurate as we can, right? Because type 2 heteroskedasticity mainly impacts type 2 error. It can do both, but type 2 is the one that we really want to avoid. Okay, so regress performance on a group membership, remember, is 0, 1 again, or we dummy code for the 3 or more groups. The predictor scores, and finally the cross product, and we can do centering if we want to. Centering doesn't change the results, but it can help with interpretation. And then we look at the output, and the first thing we look at is that interaction term, and if it's significant, there is slope bias in our test, and the test should be discontinued. So we're in violation of the law at that point and need to revamp our test or get a new one. If there is an intercept, the intercept test is significant, then that is an indicator of potential test bias, but not necessarily. So I will go into that here in the next slide. And that is the B weight for the groups. So if you look at the group membership B weight, and if that is significant, then that is a potential issue. Again, if slope bias is significant, then that's easy. There is always test bias when that's significant. But if the group membership B weight or weights are significant, then that means that we have the potential for test bias. Okay, so in Mead and Fetzer Table 2, they have a little decision tree for understanding which combination of these tests are indicative of test bias. And I don't want you to know this for the exam. Here's the table actually on the next slide. I don't want you to know this for the exam and all these different decision points. I don't want you to memorize these, but what you can memorize and what you'd need to talk about on a job interview is case 1. So understanding a pretty large gap on the predictor with no gap or very little gap on the criterion, that is a cause for concern. And so to the extent that there's a big difference in this gap from this gap, and so we could have a tiny gap here, a very large gap here, that would also be bad. So you don't have to memorize that whole chart to understand conceptually what's going on and be able to explain it. But this is helpful for reference, I think. I think this is just best in the category of reference for later. But know where the clear test bias comes into play, conceptually with the graph maybe. Okay, so for the intercept test, which we run in our MMR, if it's not significant, and again, assuming slope tests are also not significant, so no interaction there. If we have no intercept bias, then note that the test is always okay. So it gives you a nice, easy way to, regardless if you have predictor differences, regardless of criterion differences, the test will always be okay. The issue comes in when you run the MMR and the group B weight or weights are significant. And then that is a necessary but insufficient condition for bias. And you'll want to look at the predictor tests and the criterion tests that you ran in steps 1 and 2. So, and then make a decision from there. Okay, and some of this they explain, this is technical detail that they explain in the paper, so don't worry about knowing that. So the test, as far as not using it, Sunny just said hello. As far as, okay, so if there's significant intercept test, and then we have a significant predictor test, and then we have the criterion test not being significant. That is the worst case, and we cannot use the test, or we should discontinue. And that is, again, represented here. I think it's easier to memorize this and explain it than to worry about this whole table, but whatever is easiest for you. Okay, Sunny? Hey. In summary, bias occurs when a factor is present that is necessary for doing well on the test, like you have vocab, reading skills, or things like that, but it's conceptually distinct from cognitive ability, and it is correlated with race or gender or whatever groups we're looking at. So that's the issue. So a bias test picks up variance that is correlated with the group and the focal construct, but is not relevant to the focal construct. So it is not part of the construct domain, as we would say. So it represents some contamination there. So for example, a test includes item content that represents construct contamination that favors one group over another. So I'm trying to think of a concrete example of that. That would be like, a lot of times we talk about examples where tests favor white people over African Americans, just understanding white culture, having more opportunity and education. You'll do well on this test, but that is not what the focal construct is getting at. It would be like taking a cognitive ability test that had a lot of references to African American pop culture, and then white people would have trouble passing it, just because knowledge of African American culture will help you answer the items better than if you didn't have that knowledge. So I like to think about it in reverse sometimes, like what would disadvantage me if I was taking a test? Well, if it had lingo, cultural references I'm unfamiliar with, that would help me do better if I knew those things. And so a test like that would favor African Americans because they would be a little more well-versed in the item content. I mean, not across the board, right? We don't want to make stereotypes like all African Americans understand all African American cultures. That's not the case. It's just over, like in general. In the whole. And so we're going to have these group differences within, of course, variations around that, but the group differences will be revealed when we run the two groups side by side as far as their performances. Okay, well, that is hopefully a summary that will be helpful for you. You didn't have to read Mead and Fetzer, but it's there for you if you ever want to reference it. My apologies for Sunny interrupting here at the end, but since I don't want to re-record this, I'm going to leave it in. So consider it a hello from Sunny. All right, take care, thank you, and I will see you in class.